Hi everyone. So we are solving valid Sudoku question right now. So the question here says that we have a 9x9 board as shown in this example here, and we have to determine if the board is valid. So the trick here is that we only have to tell if the board is valid. We don't have to tell if a valid board, if this board can be solved, if it is valid. So that's the main part here. How do we validate if a Sudoku board is valid? We have the three rules here. So the first rule says, let's say we have a look at any row. The numbers between 1 to 9 can't be repeated. The second rule says that if we look at any column, the numbers between 1 to 9 cannot be repeated. And the third rule says that we have a 9x9 grid, right? And in that we have three subgrids. So we have 9 subgrids. So in every grid, there can't be a repetition between the number 1 to 9. So we see in this grid we have 5, 3, 6, 9, 8. Then in second grid we have 7, 1, 9, 5. Then in third grid we have 6. In fourth grid we have 8, 4, 7, and so on and so forth. Now we also have this thing which is like we only need to take care of the filled cells. We don't need to take care of the unfilled cells. And in here we see in the input format the unfilled cells are denoted by a full stop. So yeah, coming to the solution, I'll tell you one thing. How many rows do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. And in each row there can't be a repetition. So we can store the elements in each row or the characters in each row in a set. And if a character is already present, we know that it is invalid. We can return false then and there. Same for the column. We see that we have 9 columns here. So for every column, we can store the characters which are filled in the hash set or the set. And then we can check if there's a duplicate element. We'll get to know and then we can return false. Now the third one is the one which is a bit tricky, which basically says we cannot have numbers repeated in a particular subgrid. Now we have 9 subgrids. Now in every grid, we can store the numbers in every grid in a set. Same approach here. But how will we know the grid number is the question. So let's see. There's this thing. Like let's say if my I is 0, 1 and 2. If my I is let's say in between 0 to 2. Then here in here my j value 0, 1, 2, 3, 4, 5, 6, 7, 8. And my j by 3 gives me either 0 or 1 or 2, right? It will give me 3 numbers, correct? So what are the grid numbers here? 0, 1 and 2. So can we get the grid numbers in I range 0 to 2 using j by 3 formula? Yes, we can. Now next, let's say if my I is in between 3 to 5. What happens? My j by 3 will give me 0, 1 and 2. But we need 3 plus j by 3. And let's say my I is 3. So how did we get 3 here? We'll come to how this formula is, but it's basically I by 3, I into 3 by 3. So if we do this, this is how the formula works. Let's see. Let's see. If my I is between 6 to 8, my j will be between 0, 1 and 2. And I want 6 added to it. 0, 1, 2, 3, 4, 5, 6. So that perfect grid number can be attained. So if let's say my I is 6, so 6 into 3 by 6 by 3, sorry. What will we get? we'll get 6, right? Or 7 or 8, anything. So my I into 3 by 3 plus j by 3 is the formula for getting the grid number. Now let's start with the coding part. So let's say, firstly I'll have 9 sets. I mean 3 sets array for row, column, and grid. So let's say I have set of which will store characters, and we'll have an array of this since we have 9 rows, 9 columns, and 9 grid. Then let's first draw rows, row grid. Okay. And then we'll have new hash set. What's the size? We have 9. Same we'll do for column and grid. Same now we'll have column grid. Then we'll have row set, sorry. Row set, column set, and grid set. Let's use camel casing here. Now we are going to initialize these with an empty hash set so that we don't get a null pointed exception. So what are we going to do here is that my row set at ith row will be initialized to a new hash set, empty. Same we'll do for column and grid. So let's rename this here to column and here to grid. So this is to avoid an unpointed exception. Okay, now what are we going to do? We are going to iterate in the board. So let's do that. So for int row equal to 0, row is less than 9, row plus plus. Then we have column. So how many columns are there for each row? 9. So int column is less than 9, column plus plus. Right? Now my character is equal to board of row and column. Right? Now if my character is equal to a full stop, it means that we don't have to do anything. So only when it is not equal to a full stop, it means we have to check for things, right? So what do we have to check? First, we have to check if the current number is not in my current row. So, Boolean is present in row. How do we check if an element is present in row? Let's say my row set at index row contains an element with value ch. It means that we have that element present in row. Same we'll do for column and grid. So if present in column will be denoted by column set. We'll check if my column set of that column contains my character. And then I'm going to check for grid. So grid of grid number. So how do we calculate grid number? We saw the formula. It was I, which is row, into 3 by 3 plus, or let's say 3 by 3 will cancel out. So row plus column by 3. So this is how the formula looks like. Correct. Now, if my element is present anywhere, either in row or in column or in grid, then we know that it is not a valid Sudoku board, right? So then here we return false immediately. Else what happens is we put the character in our row set, column set, and grid set. So my row set dot row set of row, we are going to add ch We're also going to add it in our column because we've seen that in this column, and we are also going to add this in our grid. So this is how we go about it. And in the end, when we come out of the loop, we return true since we did not get any violations. So let's run this code. Oh yeah. So the word is character. I mistakenly wrote an extra S. We're getting a false here, but it's true. So let's see what is the grid number. So basically, we had derived the formula rho into 3, rho by 3 into 3. So this was integer division, so we needed to take care of this. So this was the error. And yeah, let's submit the code. So now let's come to the time and space complexity. So this loop runs for 9 times. This loop runs for 81 times, big O of n square. And we have 3 arrays which have which can at max hold 9 numbers. So our time and space complexity is constant. Same with space, it is constant as well. So yeah, that was it from my end. Thank you for watching. Bye.